All right, 3.8, inverse trig functions. The way inverse trig functions work, okay, here's what's really cool. This is our last set of derivative rules, okay? After this, no more. Yay. Okay, so here we go. As far as this is concerned, so you need these last three, they look complicated. They are, okay? The thing is with these is you might see only 2 questions on the AP exam. So you're only going to need to know these 2, or these 3, excuse me, for 2 questions. So here's what my advice to you is that if you are struggling with knowing all the other rules, wait on these, okay? Do the homework, but wait on these and trying to memorize these until the very end. If you already got the other rules, you're like, dude, I got this, then start working with these. These are not easy to memorize. It's very difficult for me to even memorize them, okay? So here they are. So you have inverse sine, inverse tangent, inverse secant. Remember your inverse cosine, inverse sine, inverse tangent, inverse secant, all these functions here are the reverse of your sine functions. Your sine functions take a radian measure and translate it into a number, okay? Inverse sine, inverse tangent, inverse secant all take a number and turn it into a radian measure. Cool? All right, so the derivatives of inverse cofunctions, that's the other part you need to know. So like, for instance, cosine, cotangent, cosecant, they're the exact same things, but negative. Okay? Next. So here's an example. We want to go ahead and take the derivative of inverse sine of x squared. So I will go and take this, and I say to myself, which one of these many rules do I get to choose from? Okay? For those of you not watching or watching at home, you don't see that I'm holding the paper. So here we go. There we go. So I'm going to go ahead and do this. I want to take the derivative of inverse sine. So it's going to be 1 over the square root, 1 minus, and it says there u squared. So, but u squared is, this is here. That's my u. So that'll be x squared, okay, times, because it's a chain rule, derivative of my chocolate is 2x. Okay, I go ahead and I can simplify. This would be 2x over square root of 1 minus x to the 4th. Ta-da, done. Pink. All right. Next one is an application problem. So I got a particle that moves along the x-axis, so its position at any time t is greater than 0 is given by this. What is the velocity of the particle when t is equal to 16? Okay, velocity. Velocity means I take the derivative. Take the derivative means, oh, I have a handy-dandy formula for that. Okay, so my derivative, so my velocity is going to be equal to 1 over 1 plus u squared. Again, here's my u. That's my u. U squared is going to be, so that's the square root of t squared, times, okay, derivative of u, which should be 1/2 t to the negative 1/2. Again, simplifying this out, I'd be able to see that this is 1 over, okay, 2 times the square root of t. That's from this over here. The 2's on the bottom. The t to the negative 1/2 is saying the square root of t is on the bottom, times 1 plus t. Think. And now I go ahead and from there and I solve for 16. So v of 16 is equal to 2 times the square root of 16 times 17. Woo! Okay. Answer is then 1 over 136. Cool. And then I say velocity. Velocity is, they don't tell me anything, so I'll leave it at 1 over 136. Next. All right. Taking derivative of secant. Again, just an example of using the rule. Okay. So when I do this, this is again u. So when I take a look at my wonderful, this is the complicated one. The derivative is then going to be equal to 1 over the absolute value of u, which is 5x to the 4th, times the square root of u squared, so 5x to the 4th squared, minus 1. Yeah, I know. Trying to understand all these rules, it's like, oh my god, how can I keep it all inside? Then I say times derivative of u. That's the easy part, 20x cubed. Okay? Then I go ahead and simplify. Okay, what I'm going to notice here, this is what you should notice, is that x to the 4th, no matter what I input for x to the 4th, it's always going to be positive. So I really don't need the absolute value in this particular case. If it was x cubed, x to the 5th, something that will the positive and negative changes, then I do still need to have the absolute value. But since I don't, okay, I can simplify. And so again, 20 over 5, that's 4. X cubed, that's going to go away, and I end up with an x times the square root of 25 x to the 8th minus 1. Okay, and that's it. That's all there is to it. I say, last but not least, one more. We got one more set of rules. Okay, so if you ever taken a look at your calculator while you're looking at doing this video, you're looking at your calculator going, I don't see an inverse secant, an inverse cotangent, or inverse cosecant on my lovely calculator. And you'd be right. Okay? So if you're trying to find out what the values of inverse cotangent, inverse secant, and inverse cosecant are, these are handy to have. Again, I'm going to say this. I have yet to see a question to where they ask you to use this where you have to know how is cotangent and tangent related to each other so that you can change it in your calculator. I haven't seen it. It's one of those things to where, like, if you are a math person and you love math and you just want to memorize this stuff, go for it. Be the woman, be the man, okay? But you don't have to, all right? That's what I'm going to say about this, okay? But because there might be some examples in your homework, I have to show you and tell you. Next, so how does this work in an example? Okay, so let's find the equation of a line tangent to the graph at here. Oh, that seems very simple. Okay, inverse cotangent. Okay, so tangent to the graph, again, what do I need? I need a point and I need a slope. My point for this is going to be a -1, comma, I don't know, and my slope I don't know. They really don't give me a whole lot. Okay. Again, normally what you would do is you go ahead and take your x and plug it in, okay? But your calculator, you really can't do this too well. So one of the things that you can do to help you out with the calculator, first, because it's cotangent, so it's one from the previous slide as being cotangent inverse of x is equal to pi over 2 minus tangent inverse of x. Okay? So when I go ahead and I plug in, I'm going to make my y is going to equal to this for this particular example of trying to find out my value inside the calculator. So on your calculator, you can go ahead and put on there pi over 2 minus tangent inverse of -1. Okay. What makes this confusing is you have to realize where your calculator is going to spell out the right answer. But what makes this confusing is that you have to know where inverse tangent's domain is. Again, don't freak out. This doesn't show up on the AP exam, but you need to try and understand this as far as just good math. Okay, good math. It's good math. So tangent inverse -1. Okay, in the domain of inverse tangent is going to actually be negative pi over 4. Okay, and so I have pi over 2. And it's equal to that, so then that is equal to a positive 3 pi over 4. Okay, well, what is that? Well, that's when I plugged in, -1, so this is my value of cotangent inverse at -1. Okay, so that's my y coordinate, 3 pi over 4. So now finding my slope. My slope is actually significantly easier to find compared to what I just did. Okay, so the significantly easier part of that is going, well, cotangent, the derivative of inverse cotangent is just the negative of inverse tangent, which sounds complicated, but it's just read the formula, it's okay. So when I do this, this becomes inverse, so derivative is going to be, so derivative of cotangent inverse of x is equal to negative 1 over 1 plus u squared. Again, there's my u. Okay. Change colors. That's my u. Okay, so u squared in that case is going to be x squared times the derivative of x, which is just 1. So there's that. And so if I want to find my derivative at 1, be 1 or negative 1, 1 over 1 plus negative 1 squared is equal to 1 over 2, which is my slope. And from there, my equation of the graph would be y minus 3 pi over 4 is equal to 1/2 x plus 1. Ta-da, we're done. And that's the end of the lesson. So here's your homework. Okay, questions are always welcome. In fact, I will take questions now as soon as you type them in. See ya.